There you go, and begin. Action.
Okay, so yes. I'm attending this conference and I was invited to talk to this conference. This conference is very nice. It's the first time I'm here in Benasque. It's very nice since it covers a lot of topics on carbon nanomaterials and TMDs, for instance, and I came here and I spoke about especially carbon nanostructures such as vertically aligned carbon nanotubes, which are macroscopic networks aligned vertically on a substrate. And the purpose of my talk was to show how our fundamental research were serving and deserving the industry applications, and basically in the area of energy storage. So yes, vertically aligned carbon nanotubes, they are well known in the literature. A lot of groups knows how to grow them at the moment. And you have either single wall vertically aligned carbon nanotubes, double walls, or even multi-wall vertically aligned carbon nanotubes. And some techniques grow them by a two-step process, which involves the formation of first a layer of catalyst, which is needed for the growth of nanotubes, and then second, the growth of nanotubes on this layer of catalyst. And another family of technique, which is called the one-step techniques, relies on the formation of the catalyst and the nanotubes together by filling a reactor with both precursor, the carbon source and the metallic source. So this technique is known as a one-step process, and this technique is easily operated. And at the moment, this technique needed to be upscaled, so that's what we did. But before doing that, we needed to know the principle and the mechanism and the physical chemical mechanism at play that governs the formation of those nanotubes. So in the past we were studying all of that, showing the different physical chemical mechanism at play, and demonstrating that we have a base growth mechanism, demonstrated that we can control the size of the catalyst particles and the density of those catalyst particles, and this has a strong impact on the characteristics of such carpets in terms of density of carpets, nanotube diameter, and as well the thickness of those carpets. And by controlling that and by developing the growth on different substrate, then we can go to different applications. And one of them is the supercapacitor electrodes. So in the past, 7 years ago, we demonstrated that it was possible to make supercapacitor electrodes by covering the nanotubes with a pseudo-capacitive materials, basically an electronically conducting polymer. This was demonstrated with our colleagues in the University of Cergy-Pontoise, Pierre-Henri Aubert especially, Dr. Pierre-Henri Aubert, and then at the same time we had in mind to develop at large scale this process, and we had a colleague, Pascal Boulanger, who is now the head of Nawa Technology Companies, who was interested in that. So we did this upscaling, and both of them, the development of supercapacitor electrodes and the mass production, the upscaling was done at approximately the same time. And then they merged together, and we went through the upscaling and the industrial production. But for that, and to develop such supercapacitor electrodes, we needed to adjust our synthesis process on aluminum substrate. And basically, we did some fundamental research, fundamental studies on this aluminum, showing that it was possible to grow this with this one-step process, such carpets on aluminum, which is not commonly done in the literature. At least it's most of the time done with a two-step process. So we managed to do that, and then we managed to understand the growth and especially the control of the thickness of the carpets according to the duration, and to understand the limitation of the height. And now by controlling the quantity of carbon source, we managed to improve the thickness of the carpet and to increase the thickness of the carpet. So these carpets, they were tested for electrodes for supercapacitor, and we end up with, in collaboration with our colleagues in the University of Cergy-Pontoise and as well as our colleagues in University of Tours, we ended up with an energy density and a power density which is higher for some systems, not for all the systems, but for some of them, especially the electronic double layer capacitor. We ended up with performances which were higher than the activated carbon. And basically our colleagues in Tours, Dr. François Tranvan and Dr. Fouad Gamos, they made the devices and they checked all these performances. And in the end, this is of course very interesting for NAWA technology, and NAWA Technologies is now focused on the industrial production of such carpet. They demonstrated the roll-to-roll process through the technological transfer of our synthesis conditions, and now they are on the way for the commercialization of such supercapacitor. So yes, we still need to improve some parameters of our process. I think there is still a lot of things to do with these vertically aligned carbon nanotubes for some other applications different from the one for this supercapacitor. For instance, for catalysis. Because they develop a huge surface and you can put catalyst on them. So for environmental application, there could be very useful. And regarding the synthesis, our responsibility as well to fit with the environmental condition and challenges of the actual society. Our responsibility is to develop this process on a sustainable approach. So that's what we will do, I think, in the next future.
Thank you.
That's it.
Thank you. That's it.